Parts 8, 9, and 10 of this governance series covered the upstream layer, centers of excellence that bridge policy and execution, the death valley between IT control and business velocity, contextual engineering as the discipline that turns motion into measurable progress. That foundation matters. Without it, you get governance theater, shadow AI, and paralyzed organizations watching competitors move faster. But here's what I've learned watching enterprises deploy autonomous AI systems over the last 18 months. Upstream governance does not prevent downstream disasters. You can have perfect policies, mature councils, and well-designed centers of excellence. Then an AI agent gives away services a customer support manager never authorized. Or a deployment sits in a pilot purgatory forever because nobody can answer whether the system has the right to act without human oversight. The problem is not lack of governance. The problem is the gap between the policy that should happen and what systems are actually allowed to do when decisions bind to reality. This is where the next phase of AI governance lives. This is the gap between policy and reality. Governance, Part 11. Why upstream governance stops working the moment AI systems start making decisions. Section 1. What upstream governance actually accomplished. The governance work in Parts 8, 9, and 10 I published 6 months ago is not outdated effort. I established the organizational foundation every enterprise needs before AI systems can operate at scale. Part 8 introduced centers of excellence as the execution engine missing from most AI strategies. The COE translates board policy into shared platforms, standard patterns, and embedded controls that make innovation safe instead of fragile. Without the structure, teams reinvent infrastructure for every project. Governance becomes bottleneck theater, and nobody can answer who owns the bridge between compliance and creativity. Part 9 named the structural tension killing most AI initiatives. IT-led governance strangles business velocity because IT does not understand customer problems or market timing. Shadow AI explodes when approval processes take 90 days and competitive response requires weeks. The COE built around business ownership rather than IT infrastructure solves this by putting execution authority closer to customer outcomes. Part 10 defined contextual engineering as the constraint-first operational model that turns AI motion into measurable progress. Organizations are not paralyzed. They're moving fast with budgets, vendors, and talent all in motion. But results are not. Contextual engineering connects policy to delivery by designing with actual constraints rather than hoping frameworks transfer without adaptation. The upstream work creates the foundation. It does not create the enforcement. Section 2. The over-provision disaster. Enterprises enthusiastic about AI capabilities are discovering what happens when systems are given authority without boundaries. Customer service agents are resolving tickets by offering discounts, credits, and service upgrades that nobody in finance authorized. The agent has access to the customer record, the ability to modify accounts, and instructions to solve problems. What it does not have is a mechanism that says you can offer up this amount and nothing more. The first time a customer asks for a refund outside policy guidelines, the agent complies because nothing stopped it. Procurement agents are placing orders with vendors based on inventory predictions and delivery timelines. The agent has access to supplier systems, authorization to create purchase orders, and instructions to maintain stock levels. What it does not have is the boundary that says you can commit to purchases under this threshold automatically, and everything above requires human review. The first time a supply chain disruption triggers an unusual order pattern, the agent commits to expenditures that blow the quarterly budget because nothing prevented it. Marketing agents are launching campaigns, adjusting ad spend, and targeting audience segments based on performance data. The agent has access to advertising platforms, budget allocation tools, and instructions to optimize conversion rates. What it does not have is enforcement that says you can modify spend within these parameters, and campaign changes beyond this scope require approval. The first time an algorithm detects an opportunity in a sensitive demographic or controversial topic area, the agent acts because nothing blocked it. These are not malicious AI scenarios. They are capability without constraint. The agents are doing exactly what they were designed to do: solve problems, optimize outcome, act autonomously. Disaster happens because upstream governance said what the agent should do without defining what the agent is allowed to do at the moment a decision binds to reality. Section 3. The under-deploy paralysis. Enterprises cautious about AI risk are stuck in the opposite failure mode. They run pilots that work in controlled environments. The model performs well. The business sponsor is enthusiastic. The ROI projections look convincing. Then a deployment review happens. Legal asks how we prove the system had the right to make this decision if a customer challenges it. Compliance asks how do we demonstrate to regulators that appropriate oversight was in place when the action occurred. Security asks how we prevent the system from being manipulated into taking actions outside its intended scope. Nobody can answer these questions because upstream governance defined policies, not enforcement mechanisms. The policy says AI systems must operate within approved parameters. It does not say what the approved parameters means in executable terms. The policy says human oversight is required for high-risk decisions. It does not define high risk in a way a system can evaluate in real time. The policy says audit trails must demonstrate accountability. It does not specify what evidence is sufficient to prove the system acted within authority. Deployment stalls, not because the technology failed, because nobody can prove the system is safe to operate without constrained human supervision. The pilot becomes permanent. The business case dies. The team moves on to other projects. The organization adds another data point to the 80% AI project failure statistic. Section 4. Why post hoc governance creates liability. The instinct when these failures happen is to add more oversight after the fact. Logs capture what the system did. Audit trails document when actions occurred. Explainability frameworks describe why the system made specific decisions. Review processes examine whether outcomes align with policy intent. This is governance as homework marking. The system acts, then humans evaluate whether the action was acceptable. That approach worked when AI systems made recommendations that humans executed. A human reviewed the AI output, applied judgment, and took responsibility for the action. If the recommendation was wrong, the human caught it before consequence occurred. That approach fails when AI systems make decisions that bind immediately to reality. The customer service agent already issued the credit. The procurement agent already committed to the purchase. The marketing agent launched the campaign. By the time logs are reviewed and audit trails are examined, the action is complete and consequences are in motion. Post hoc governance does not create control. It creates liability with documentation. You can prove what happened. You cannot prove the system had the right to act in that moment. That distinction matters when regulators ask questions, when customers challenge decisions, and when boards want accountability for autonomous system failures. Section 5. What the next phase requires. The gap between policy and reality closes when governance moves from defining intent to enforcing boundaries at the commitment point. Not more policies, not better councils, not additional oversight committees. Enforcement mechanisms that answer 3 questions before a system act. 1. Is the action within the scope of authority granted to the system? 2. Does the system have verified access to the data and resources required for this action? 3. Can the system prove in real time that executing this action is admissible under current policy? If the answer is yes to all 3, the system acts. If the answer to any is no, the system either escalates to human authority or refuses the action entirely, not after logging and review, before consequence. This is not new thinking. This is AppSec, DevSecOps, OPSEC, and CIAM principles applied to AI inference workflows. Decades of security engineering taught us to enforce boundaries at commit time. Code reviews happen before deployment, not after production failures. Access controls prevent unauthorized actions, not document them after they occur. Least privilege limits blast radius, not explains damage after incidents. AI systems require the same discipline adapted to inference decision points. The remaining articles in this mini arc cover how to build it.